Welcome to EC Elimu Learning Simplified and welcome to this lesson. In the previous lesson, we discussed parallel forces and we said the algebraic sum of parallel forces is 0. That means the sum of forces acting on one side of a body which is at a state of balance is equal to the force or to the sum of the forces acting on the other side. So in this lesson, we are going to discuss how to solve different problems involving parallel forces. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to solve problems involving parallel forces. So the first question reads, a uniform meter rule. Here you should be very keen on this uniform meter rule. Pivoted at its center is balanced by a force 100 Newton at 20 centimeter and another force F at 75 centimeter mark. The first question is calculate the force F, and then the second one is find or what is the reaction at the pivot. At this pivot, we are going to find the reaction. And reaction, remember, this force is exerting action. Then this pivot is going to give out reaction. Remember, action and reaction are equal and opposite. So in this case, we are going to begin with the first one. The first one, we are going to use the principle of moment, which says sum of clockwise moment is equal to the sum of anticlockwise moment. So if this force 100, we give it F2, and the distance from the pivot, we give it D2, and then this F which we are looking for, we give it F1, and the distance from the pivot, we give it D1. So in this case, D1 is 75 minus 50, which is 25 centimeter. Then D2 is 50 minus 20, which is the same as 30 centimeter. Then now in this case, we are going also to analyze which force gives clockwise moment. This force here, F1, is the one which will give this metal or this meter rule a clockwise moment. So this one will give clockwise moment. And then this F2 is going to give it anti-clockwise moment. So in this case, for us to calculate the first one, F, then we are going to say sum of clockwise moment is equal to the sum of anti-clockwise moment. Then can we find clockwise moment? Yes, which is the same as F1 times D1 will be equal to the sum of anti-clockwise moment, which is F2 D2. Now, do we have F1? No, that's what we are looking for. F1 times D1 is 25 centimeter, which we can use like that, or we change it to SI unit. In this case, I would encourage for us to change it in SI unit, which is 25 divided by 100 meter is equals to sum of anticlockwise moment. We have F2, which is 100 Newton, times D2. In this case, it is 30. 50 minus 20, 30. 30 in this case in centimeter. We make it meter by dividing it by 100. Then now in this case, we will have our sum of clockwise moment to be 0.25 meter times F1, which is the same as sum of anticlockwise moment, which is 0.3 meter times 100 Newton. So in this case, it's going to be 0.25 meter F1 is equals to this one. If we multiply 0.3 times 100 is going to give us 30 Newton meter. Then for us to get F1, then we are going to divide by 0.25 meter on both sides, 0.25 meter. Then here it's going to be, this one will cancel one, then meter go with meter, and then now it will be our F1 is going to be 30 Newton divided by 0.25. In this case, 30 divided by 0.25 is going to give us 120 newtons. So the force F which we are looking for here is 120 newtons. Then now the second question is, what is the reaction at the pivot? From the parallel forces, we said it's the sum of forces on one side is equal to the sum of the forces on the other side. Then in this case, the only forces which are on the downward are 100 and F1, which is 120. Then now this rule is exerting action on this pivot. Then the pivot is going to exert reaction. So we only have one force which is moving up, which is a reaction. And this reaction is acting upwards, and it's the only force which is upwards. So from parallel forces, we said sum of downward forces is equals to the sum of upward forces. The algebraic sum is 0. So in this case, if you add upwards and downward, you will get 0. So in this case, we are going to have sum of downward force is 120 Newton plus 100 Newton, and it should be the same as sum of upward force, which we are looking for reaction. So in this case, our reaction is going to be 220 Newtons. So another question, and it's a very good question since it combines two ideas. One, we discussed it in Form 1 hydraulic machines, and now we are combining it with moments, especially on parallel forces. So in this case, the figure shows an hydraulic press system using a lever of negligible mass on the side of a smaller piston at point P. So here we have a piston at this point P. That's where we have our piston. And then a force of 100 Newton is applied at point R. We have point R here, and we have, let's call it F1, which is applied at that point R. Then the question is, calculate the force F exerted by the small piston on the fluid. So here we want to calculate a force F. Let's say there is a force which will be exerted by this piston down into this fluid. In this case, let's call it F2. Now here, since we have also distances from point R to this piston, that is 8 centimeter. From the pivot to the piston is 30 centimeter. Then in this case, we are going to use the principle of moment to calculate this force F2, which we don't have. And in this case, if we use the principle of moment, then let's handle the first one. Then in this case, a sum of clockwise moments is equal to the sum of anti-clockwise moments. Then now in this case, which force is giving us a clockwise moment? Here, F1, if you pull this F1 down, it's going to make this bar to move in this direction. And if it moves in this direction, this is anti-clockwise moment. Then now, when you are moving it down, it's also going to make this piston to push this liquid down. And at the same time, the whole bar will be moving down. So in this case, when it's moving down, this F2 will also be moving down. So at the same time, this is clockwise moment. But in this case, the force which will make this rule to move in anti-clockwise direction is the reaction. There's a force which will be exerted by this liquid upwards. Because remember, we said action, this is action here, and reaction. Action and reaction are opposite and equal. So when you place this piston down, it will experience an upward force which will be caused by this fluid, which is anti-clockwise. And this upward force, it is the one now which will make this bar to move like this, which will be anti-clockwise, not anti-clockwise, but clockwise direction. This is a clockwise direction. So this clockwise moment. So the reaction force is the one which is going to give it a reaction or anti-clockwise direction. So in this case, for us to calculate moment here, then if we know the pivot, because the moment says the force times the perpendicular distance from the pivot. So the first moment here, which will be anti-clockwise direction, will be the distance from this force to the pivot, the whole of this distance here. This one will be our D1, which is 80 plus 30. And now for us to get the, 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 the distance for F2, which will be action and the reaction, that is what we are interested in, then it should be the force where it is acting is at this point to the pivot. This will be our D2, which is 30 centimeters. So in this case now, if we replace that one, F1 D1, F1 D1 is equals to F2 D2, but D2, remember now, F2 is the reaction, not the action, because action is going to make this one also to move down. The reaction is the one which will push it up, and this is the idea that we want to bring in this question as parallel forces. So now if we replace this F1, which is 100 Newton, times D1. D1 is from the force to the pivot, that is 80 plus 30, which is 100 centimeter, that is anti-clockwise moment. Then it will be equals to clockwise moment, which is F2, which we don't know. F2 is the same as the reaction, also this F2. Then times the distance from the pivot, that is 30 centimeter, 30 centimeter. So in this case, the clockwise moment, if we change this to meters, 100 centimeter, it will be 1 meter. Then in this case, we will have our anti-clockwise moment as 100 Newton times 1 meter is equals to F2, which we are looking for. In this case, the reaction or the action at the same time is the same as reaction, times 30 centimeter, which is the same as 0.3 meter. Then here, if we want F2, we will divide by 0.3 meter, 0.3 meter on both sides. Then here 0.3 meter. Then we will remain with our F2 is equals to 100 Newton meter divided by 0.3 meter. In this case, if meter cancel with meter, then our F2 is going to be 100 divided by 0.3, which is going to be 333.33 Newton as our force 2. So the force which will be caused here as F2 is 333.33, and this force which will be downwards on this fluid, the fluid will exert a reaction which is equal to that, and the reaction is the one now which we have used to find this force here using the principle of moment. Then now the second question asks us to find the weight of the bell supported by the large piston. This one now you can use the fluid equation, that is force 1 over area 1 is equals to force 2 over area 2. In this case, our force 1 here is going to be this one, 333 on the smaller piston. Then our force 2 is going to be the force which is exerted by this bell. So in this case, it will be force 1 is 333.33 divided by area 1, which is 60 centimeter square, is equals to force 2, which we are looking for, over area 2. Area 2 is 200 centimeters cubed. And in this case, on the left hand side, that is 333.33. If you divide it by 60 centimeter, then pressure on this side will be equals to 5.555 and newtons per centimeter square, then which will be equals to F2 over 200. So for us to get F2, then we multiply 200 centimeters square times this 5.5555. Then in this case, it's going to be this 5.555, which is 5.555 newtons per centimeter square times 200 centimeter square. So in this case, centimeter square will cancel with that. then we will remain with 5.555 times 200, which is going to give us 11. So F2 is going to be 1111.1 Newton. So in this case, the second part majorly rely on the idea that you discussed in Form 2 pressure, but we were interested on the first part, which talks about the reaction and action and how you can use it to find the clockwise and anti-clockwise moments. So the other question reads, three forces are applied on a meter rule as shown below. So we have different forces here. We have, let's call this one F1, and then the distance from the pivot, let's call it D1. Then we have this one as F2, the distance from the pivot, let's call it D2. Then we have this one as our F3, and then the distance from the pivot to this force D3, let's call it D3. This case, the first question reads, calculate the force F. We want to find the force F, this one here, F2. In this case, we have to determine which force gives a clockwise and anti-clockwise. F1 will make this rule to move like this, which is anti-clockwise direction. Then this F2 is going to make it to move like this, clockwise moment. Then this one F3 also is a clockwise moment. So we have two clockwise moments and one anti-clockwise moment. So if we handle the first one, sum of clockwise moments is equal to the sum of anti-clockwise moments. In this case, clockwise moments, we have two of them. We have F2 D2 plus F3 D3. This is clockwise moment is the same as F1 D1, which is anti-clockwise moment. So in this case, if we replace F2, which we don't have, times D2, which is 70 minus 50, D2 here it is 20 centimeter, which is the same as 0.2 meter if we convert it to meters, then plus F3 D3, F3 is 30 newtons, times D3 is 90 minus 50, here it is 40 centimeter, which is the same as 0.4 meter. Then it should be equal to anti-clockwise moment, which is 72 newtons, times D1. D1 is 50 minus 0, which is 50 centimeter, which is the same as 0.5 meter. So in this case, if we solve this one, the first case here for clockwise moment, it will be 0.2 meter F2 plus 30 times 0.4, which is the same as 12 Newton meter, is equals to 72 times 0.5. This is the same as 36 Newton meter. So in this case, like terms together, this is a like term, Newton meter. We take this the other side, then we will remain with 0.2 meter F2 is equals to 36 Newton meter minus 12 Newton meter. And in this case, it's going to give us 0.2 meter F2 is equals to 36 minus 12, which is 24 Newton meter. Then if we divide by 0.2 meter, 0.2 meter on both sides, then it's going to give us 0.2 meter. This 0.2 meter on the left hand side will go, then we will remain with F2 is equals to meter, and meter will cancel out, then we will remain with 24 divided by 0.2, which is the same as 120 Newton. So the force that we must exert at F2 so that it balances the force on the left hand side is 120 Newton. Then the second question now asks us, what is the reaction at the pivot? Remember this rule and the forces are exerting action. So F1, F2 and F3 are action forces. Then in this case, we have a force or the reaction force by this pivot. Remember we said action and reaction force are equal and opposite. And in any object on top of another, there is action and reaction. So in this case, the sum of forces downwards, so forces downwards is equals to the sum of forces upwards. Sum of forces downwards is 72 plus 120 plus 30. Those are the total forces downwards. They should be equal to the reaction upwards, because upwards we only have the reaction. So in this case, for us to get a reaction force, in this case, it will be 72 plus 120 plus 30, which is going to give us 222 Newton. So the reaction in this case is going to be the sum of downward force. For parallel forces, the algebraic sum is 0. The downward force is 222 newtons. Upwards, it will also be 222 newtons. Now, this question looks like the first one that we handled. And now, since it combines with some knowledge of Form 1, I will leave it for you as an assignment. And if you get any challenge, feel free to visit ECLIMU Learning Simplified website for more and simplified questions like this. So that marks the end of our lesson today. Feel free to visit ECLIMU Learning Simplified for more materials, notes, and solutions.